Welcome to the channel. Please consider subscribing. I produce videos daily covering a wide variety of cloud topics with a focus on networking. Also, hit the bell icon to get notified of new videos. In this presentation, we will explore AWS Resource Access Manager, commonly known as RAM. This service is a fundamental tool for organizations that operate multiple AWS accounts and need to share resources efficiently across their infrastructure without duplicating them in each account. AWS RAM allows you to securely share your AWS resources with any AWS account or within your AWS organization. Instead of creating duplicate resources in multiple accounts, which increases costs and management complexity, you can create a resource once and share it with other accounts. This approach reduces operational overhead and helps maintain consistency across your environment. The service supports sharing of many resource types including VPC subnets, transit gateways, Route 53 resolver rules, license manager configurations, and many more. Understanding RAM is essential for architects designing multi-account strategies and for anyone preparing for AWS certifications. Throughout this presentation, we will cover the core concepts of RAM, the sharing workflow, supported resource types, integration with AWS organizations, security considerations, and practical CLI examples. By the end, you will have a comprehensive understanding of how to implement resource sharing in your AWS environment. The Multi-Account Challenge. Before we dive into how AWS RAM works, let us understand the problem it solves. Modern enterprises typically operate multiple AWS accounts for various reasons including security isolation, billing separation, compliance requirements, and organizational boundaries between teams or business units. Consider a scenario where you have separate accounts for development, staging, and production environments. Each account might need access to shared infrastructure components like transit gateways for network connectivity, centralized DNS resolution rules, or common license configurations. Without a sharing mechanism, you would need to recreate these resources in each account. This duplication creates several problems. First, there is increased cost because you are paying for multiple instances of the same resource. Second, there is management overhead because you need to maintain and update multiple copies. Third, there is the risk of configuration drift where resources in different accounts become inconsistent over time. Fourth, it becomes difficult to maintain a single source of truth for your infrastructure. AWS RAM addresses these challenges by enabling centralized resource management, while providing controlled access to other accounts. The diagram on the slide illustrates this challenge visually. On the left side, you see the traditional approach where each account maintains its own duplicate resources. On the right side, you see the RAM approach where a single resource is shared across multiple accounts, reducing duplication and simplifying management. AWS RAM Core Concepts. To effectively use AWS RAM, you need to understand several key concepts that form the foundation of the service. Let me walk you through each of these concepts in detail. First is the resource share. A resource share is a container that holds the resources you want to share and specifies who can access them. Think of it as a sharing policy that defines what resources are being shared and with whom. Each resource share has a unique Amazon resource name, or ARN, and can contain multiple resources and multiple principals. Second is the concept of resources. These are the actual AWS resources you want to share. Not all AWS resources are shareable through RAM, only specific resource types that AWS has enabled for sharing. For example, VPC subnets, transit gateways, and Route 53 resolver rules. Third is principals. Principals are the AWS accounts, organizational units, or entire organizations that you share resources with. When you share with an AWS account, you specify the 12-digit account ID. When sharing within an organization, you can share with the entire organization or specific organizational units. Fourth is permissions. RAM uses AWS managed permissions to define what actions principals can perform on shared resources. These are predefined permission sets that you attach to resource shares. You cannot create custom permissions, but AWS provides appropriate permissions for each resource type. The diagram on the slide shows these concepts and their relationships. The resource share sits at the center, connecting resources on one side with principals on the other, while permissions define what those principals can do with the shared resources. Resource sharing workflow. Let me walk you through the complete workflow for sharing resources using AWS Resource Access Manager. Understanding this workflow is crucial for implementing resource sharing correctly in your environment. The workflow begins in the owning account, which is the account that contains the resources to be shared. In this account, you create a resource share using the RAM console or command line interface. During creation, you specify a name for the resource share, select the resources you want to include, choose the principals you want to share with, and optionally attach specific permissions. Once the resource share is created, what happens next depends on whether you are sharing within an AWS organization or with external accounts. If you are sharing within your organization and have enabled resource sharing in the organization settings, the resources become available to the target accounts automatically without requiring acceptance. However, if you are sharing with accounts outside your organization, or if you have not enabled automatic sharing within your organization, the recipient accounts must accept the resource share invitation. The invitation appears in the RAM console of the recipient account and must be explicitly accepted before the shared resources become available. After acceptance, the shared resources appear in the recipient account as if they were native resources in that account. For example, a shared subnet will appear in the VPC console and can be used to launch EC2 instances. However, the recipient cannot modify or delete the shared resource since that control remains with the owning account. The sequence diagram on the slide illustrates this workflow step by step, showing the interactions between the resource owner and the participant account, including the creation, invitation, acceptance, and usage phases. Supported resource types. AWS RAM supports sharing of many different resource types across various AWS services. Understanding which resources can be shared is essential for designing your multi-account architecture. Let me cover the most commonly used shareable resource types. In the networking category, you can share VPC subnets, which allows instances in different accounts to be launched in the same subnet. You can share transit gateways, enabling centralized network connectivity. You can share customer-owned IP version 4 addresses from outposts, prefix lists for simplifying security group rules, and traffic mirroring targets for network analysis. For domain name system and domain services, you can share Route 53 resolver rules that define how domain name system queries are resolved. This is particularly useful for hybrid environments where you need consistent domain name system resolution across all accounts. You can also share Route 53 resolver query log configurations for centralized domain name system logging. AWS License Manager configurations can be shared to ensure license compliance across your organization. This allows you to track software licenses centrally while allowing multiple accounts to launch instances with those licenses. AWS Outposts configurations, including outposts themselves, local gateway route tables, and sites can be shared to enable multiple accounts to use the same on-premises AWS infrastructure. Other shareable resources include Aurora database clusters for cross-account database access, code build projects and report groups, EC2 image builder components and images, Glue data catalogs for data lake sharing, network firewall policies, and resource groups for organizing shared resources. The table on the slide categorizes these resource types by service area and indicates common use cases for sharing each resource type. Integration with AWS organizations. AWS RAM integrates deeply with AWS organizations to provide streamlined resource sharing within your organization. This integration offers significant benefits and simplifies the sharing process considerably. When you share resources within your organization, you can take advantage of automatic acceptance. By default, when you share resources with accounts in your organization, those accounts must still accept the invitation. However, you can enable a feature called Enable Sharing with AWS Organizations in the RAM settings. Once enabled, resource shares with accounts in your organization are automatically accepted without requiring manual intervention. You can share resources at different levels of your organization hierarchy. You can share with the entire organization, meaning all accounts in the organization will have access. You can share with specific organizational units or OAs, targeting only accounts within those OAs. Or you can share with specific accounts within the organization. When you share with an OU, any new accounts added to that OU automatically gain access to the shared resources. Similarly, if an account is moved out of an OU, it loses access to resources shared with that OU. This dynamic membership makes it easy to manage access as your organization evolves. There is an important consideration regarding trusted access. To share resources with your organization or organizational units, you must enable trusted access for RAM in your organization's management account. This allows RAM to access information about your organization structure. The management account can enable or disable this trusted access at any time. The diagram on the slide shows how resource sharing works with organization structure, demonstrating sharing at the organization level, organizational unit level, and individual account level, and how the organization hierarchy determines which accounts can access shared resources. VPC Subnet Sharing Deep Dive. VPC subnet sharing is one of the most powerful and commonly used features of AWS Resource Access Manager, or AWS RAM. It enables multiple accounts to launch their resources into shared subnets within a centrally managed VPC. Let me explain how this works in detail. With VPC sharing, you create a VPC and subnets in a central networking account. This account owns and manages the network infrastructure including the VPC, subnets, route tables, network ACLs, and Internet or NAT gateways. You then share specific subnets with other accounts, which we call participant accounts. Participant accounts can launch their resources, for example, EC2 instances, RDS databases, Lambda functions, and ECS tasks, into the shared subnets. These resources get IP addresses from the shared subnet and can communicate with other resources in the VPC. However, participant accounts cannot view or modify the VPC configuration, route tables, or other networking components. They only see and use the shared subnets. This architecture provides several benefits. It centralizes network management, reducing complexity and ensuring consistent network configuration. It enables efficient IP address utilization since multiple accounts share the same IP space. It simplifies connectivity because resources from different accounts can communicate directly within the VPC without requiring VPC peering or transit gateway attachments. Each account maintains full control over its own resources within the shared subnet. Security groups belong to the account that created the resource, so each account manages its own security group rules. This means resources from different accounts in the same subnet can have different security postures based on their individual security group configurations. The diagram on the slide illustrates the VPC sharing architecture, showing the owner account that controls the VPC infrastructure and multiple participant accounts launching their resources into shared subnets while maintaining their own security groups. Creating a resource share via command line interface. Now, let's look at how to create a resource share using the AWS command line interface. Understanding the command line interface commands gives you the ability to automate resource sharing and integrate it into your infrastructure as code workflows. The primary command for creating a resource share is AWS RAM create resource share. Let me explain each parameter in detail. The name parameter specifies a friendly name for your resource share. Choose a descriptive name that indicates what resources are being shared and for what purpose. For example, we use Network Infrastructure Share to indicate this share contains networking resources. The resource ARNs parameter is a list of ARNs for the resources you want to share. You can include multiple resource ARNs separated by spaces. In the example, we are sharing a subnet with the ARN ARN:AWS::EC2:S East 1:11:11:11:11:11:subnet/subnet 0123440. Note that the ARN includes the region, account ID, and resource identifier. The principals parameter specifies who can access the shared resources. You can specify AWS account IDs, organization ARN, or OUARNs. For example, we share with account 2222. If you want to share with your organization, you would use the organization ARN format ARN:/AWS:1111:organization/o-example.org ID. The allow external principals parameter controls whether you can share with accounts outside your organization. Set this to true if you need to share with external accounts, or false to restrict sharing to within your organization only. This provides an additional security control. The tags parameter lets you apply tags to the resource share for organization and cost allocation. Tags are specified as key equals string, value equals string pairs. The code block on the slide shows the complete command with all these parameters. After running this command, you will receive a response containing the resource share ARN and other details about the created share. Managing resource shares. After creating resource shares, you will need to manage them over time. This includes viewing existing shares, updating them with new resources or principals, and monitoring their status. Let me walk you through the key management commands. To list all resource shares in your account, use the AWS RAM get resource shares command. The resource owner parameter specifies whether to list shares where you are the owner, self, or shares that others have shared with you, other accounts. This helps you see both sides of the sharing relationship. To add resources to an existing resource share, use AWS RAM Associate Resource Share. You need to provide the resource share ARN to identify which share to update, and the resource ARNs parameter with the list of resource ARNs to add. You can add multiple resources in a single command. Similarly, to add new principals to a resource share, use the same associate resource share command but with the principals parameter instead of resource ARNs. You can also add both resources and principals in a single command by including both parameters. To remove resources or principals from a share, use AWS RAM disassociate resource share. The syntax is similar to the associate command, but it removes the specified resources or principals instead of adding them. To view the resources in a specific share, use AWS RAM list resources with the resource owner and resource share ARNs parameters. This shows you all resources associated with that share. To view the principals for a share, use AWS RAM list principals with similar parameters. This shows which accounts, OUs, or organizations have access to the share. The code block on the slide demonstrates these commands. Note how each command targets a specific resource share using its ARN and performs the appropriate action. These commands can be scripted for automation or used interactively for ad hoc management tasks. RAM permissions and security. Security is a critical aspect of resource sharing. AWS RAM uses a combination of AWS managed permissions and IAM policies to control what actions can be performed on shared resources. Understanding this security model is essential for properly securing your shared resources. AWS RAM uses managed permissions that define what actions principals can perform on shared resources. These permissions are predefined by AWS and are specific to each resource type. For example, the default permission for shared subnets allows participants to launch instances but not modifies subnet properties. You cannot create custom RAM permissions, but you can choose from available managed permissions when creating resource shares. In addition to RAM permissions, standard IAM policies still apply. When an account accesses a shared resource, both the RAM permission and the account IAM policies must allow the action. This provides defense in depth. For example, even if RAM permits launching instances in a shared subnet, the IAM policy in the participant account must also allow the EC2:run instances action. Resource-based policies on the shared resources continue to apply. For example, if you share a secrets manager secret, its resource policy still controls who can access it. The RAM share grants visibility of the resource, but the resource policy controls access. For VPC sharing specifically, security groups remain account scoped. When you launch an instance in a shared subnet, you create security groups in your own account and attach them to your instances. You cannot use security groups from other accounts. This ensures each account maintains control over its own security posture. The diagram on the slide illustrates how these different permission layers work together. It shows the RAM permissions defining share-level access, IAM policies controlling account-level permissions, and resource policies providing resource-specific access control. All three layers must permit an action for it to succeed. Transit gateway sharing. Transit gateway is one of the most valuable resources to share via AWS RAM. A transit gateway acts as a central hub that connects multiple VPCs and on-premises networks together. Sharing a transit gateway across accounts enables a hub-and-spoke network architecture without requiring each account to create and manage its own transit gateway. When you share a transit gateway, the participant accounts can attach their VPCs to the shared transit gateway. Each account creates a transit gateway attachment in their own account, associating their VPC with the shared transit gateway. The attachment includes specifying which subnets in their VPC will be used for the transit gateway network interfaces. The transit gateway owner maintains control over the routing configuration. The owner manages the transit gateway route tables, which control how traffic flows between attachments. The owner can create multiple route tables and associate different attachments with different route tables to implement network segmentation. For example, production VPCs might use a different route table than development VPCs. Participant accounts manage their own VPC route tables. They need to add routes in their VPC route tables pointing to the transit gateway attachment for traffic destined to other VPCs or on-premises networks. This allows each account to control which traffic from their VPC is sent to the transit gateway. There are important considerations for transit gateway sharing. First, attachments incur hourly charges in the account that creates them, not the transit gateway owner. Second, data transfer charges apply for traffic that crosses the transit gateway. Third, the transit gateway must have available attachment capacity, since each transit gateway has a maximum number of attachments. The diagram on the slide illustrates a typical hub-and-spoke architecture using a shared transit gateway. The network account owns the transit gateway, and multiple participant accounts have attached their VPCs. The transit gateway routes traffic between all connected networks, including the on-premises data center connected via VPN or Direct Connect. Transit gateway sharing CLI commands. Let me walk you through the command line interface commands for sharing a transit gateway and creating attachments. This workflow involves actions in both the owner account and participant accounts. First, in the owner account, you create a resource share containing the transit gateway. The command uses AWS RAM create resource share with the transit gateway ARN. Note that the ARN format for transit gateways is ARN:AWS:/EC2:region:account ID:transit gateways/TGWID. You specify the principals, which could be specific account IDs or your organization ARN. After the participant account accepts the invitation, they can view the shared transit gateway in their account. The shared transit gateway appears when they run AWS EC2 describe transit gateways in their account. The transit gateway will show the owner account as the owner ID, and the participant account will see it with a state of available. The participant account then creates a transit gateway attachment for their VPC. The command AWS EC2 create transit gateway VPC attachment requires several parameters. The transit gateway ID is the ID of the shared transit gateway. The VPC ID is the participant's own VPC that they want to connect. The subnet IDs specifies which subnets in the VPC will host the transit gateway network interfaces. Best practice is to use dedicated subnets in each availability zone for transit gateway attachments. After creating the attachment, the participant needs to update their VPC route tables. They add routes for destination CIDR blocks of other connected networks with the transit gateway attachment as the target. The command AWS EC2 create route specifies the route table ID, destination CIDR block for the remote network, and transit gateway ID as the target. Back in the owner account, the transit gateway administrator can accept the attachment if auto acceptance is disabled, associate the attachment with the appropriate route table, and add routes to the transit gateway route table for the new VPC CIDR. The code block on the slide shows these commands in sequence. Notice how the workflow alternates between the owner and participant accounts, with each party managing their respective components of the connectivity. Route 53. Resolver Rule Sharing. Route 53 resolver rules enable you to control how DNS queries are resolved in your VPCs. Sharing these rules via RAM is essential for organizations that need consistent DNS resolution across multiple accounts, especially in hybrid environments with on-premises DNS servers. There are two types of resolver rules. Forward rules direct DNS queries for specific domains to specified DNS servers. For example, you might forward queries for corp.example.com to your on-premises DNS servers. System rules override the default DNS behavior for selected domains and can be used to block resolution of certain domains. When you share a resolver rule, participant accounts can associate that rule with their VPCs. Once associated, any DNS query from resources in that VPC matching the rule's domain will be resolved according to the rule's configuration. This means all VPCs across your organization can resolve internal domains consistently without duplicating the resolver rules in each account. The typical use case is hybrid domain name system. Your central network account creates a resolver rule that forwards domain name system queries for your corporate domain to on-premise domain name system servers. These on-premise servers are accessible via a VPN or direct connect connection from the central VPC. By sharing this rule, all participant VPCs can resolve corporate domain names through the same domain name system infrastructure. Another common use case is centralized domain name system management. You might have different resolver rules for different environments. Development accounts get a rule that forwards to development domain name system servers, while production accounts get a rule for production domain name system servers. By creating different resource shares with different principals, you can control which accounts receive which rules. The diagram on the slide shows the DNS resolution flow when using shared resolver rules. A resource in a participant VPC makes a DNS query for corp.example.com. The shared resolver rule causes Route 53 resolver to forward this query to the on-premises DNS servers. The response flows back through the resolver to the requesting resource. All VPCs sharing this rule get the same DNS resolution behavior. Route 53 resolver rule CLI commands. Let me demonstrate how to create and share Route 53 resolver rules using the command line interface. This involves creating the rule, sharing it via RAM, and then associating it with VPCs in participant accounts. First, you create the resolver rule in the owner account using AWS Route 53 Resolver Create Resolver Rule. The creator request ID is a unique identifier for this request to ensure item potency. The name parameter provides a friendly name for the rule. The rule type is forward for rules that forward queries to external DNS servers. The domain name specifies which DNS queries match this rule, in our example corp.example.com. The resolver endpoint ID parameter specifies the outbound resolver endpoint that will forward the queries. You must create an outbound endpoint first with network interfaces in subnets that have connectivity to your target DNS servers. The target IPs parameter lists the IP addresses of the DNS servers that will receive the forwarded queries. Each target includes the IP address and port, typically port 53 for DNS. After creating the rule, you share it using AWS RAM Create Resource Share. The resource ARN for a resolver rule follows the format ARN:AWS:"route 53 resolver:"region:"account ID:"resolver rule/RSLVRRRID. You can share with specific accounts, organizational units, or your entire organization. In the participant account, after accepting the resource share invitation, you associate the shared rule with your VPC. The command AWS Route 53 Resolver Associate Resolver Rule requires the resolver rule ID of the shared rule, and the VPC ID of the VPC where you want DNS queries to use this rule. The name parameter provides a friendly name for this association. Once associated, any DNS query from the participant VPC for the specified domain will be forwarded according to the rule. You can verify the association using AWS Route 53 Resolver List Resolver Rule Associations in the participant account. The code block on the slide shows the complete sequence of commands. Notice how the rule is created once in the owner account and then can be associated with multiple VPCs across different accounts, providing consistent domain name system resolution everywhere. Accepting resource share invitations. When resources are shared with accounts outside your organization, or when automatic acceptance is not enabled, recipient accounts must explicitly accept resource share invitations. Understanding this process is important for both administrators sending invitations and those receiving them. When a resource share is created with your account as a principal, an invitation is generated. This invitation appears in the AWS RAM console of your account and can be viewed via the command line interface. The invitation contains details about who is sharing, what resources are included, and what permissions are granted. To view pending invitations, use the AWS RAM Get Resource Share Invitations command. This returns all invitations for your account, including pending, accepted, and rejected invitations. Each invitation has a unique ARN that you use when accepting or rejecting it. The invitation also shows the resource share name, owner account, and status. To accept an invitation, use AWS RAM Accept Resource Share Invitation with the invitation ARN. Once accepted, the shared resources become visible in your account. For example, shared subnets appear in your VPC console. Shared transit gateways appear in your transit gateway list, and shared resolver rules appear in your Route 53 resolver console. If you do not want access to the shared resources, you can reject the invitation using AWS RAM Reject Resource Share Invitation. Rejecting an invitation means the shared resources will not be accessible in your account. The owner can send a new invitation later if needed. There are important timing considerations. Invitations do not expire, but the owner can delete the resource share at any time, which removes access. If you accept an invitation and later want to remove access, you must contact the owner to remove your account from the principals list, or delete the share. The sequence diagram on the slide shows the complete invitation lifecycle. It illustrates how the invitation flows from creation to acceptance, and how the shared resources become accessible only after acceptance. The diagram also shows the alternative path of rejection and what happens when an owner revokes access. Resource Share Invitation Command Line Interface Commands. Let me walk through the CLI commands for managing resource share invitations from the participant account perspective. These commands help you view, accept, or reject invitations and verify access to shared resources. The first command, AWS RAM Get Resource Share Invitations, lists all invitations for your account. You can filter by status to see only pending invitations that require action. The output includes the invitation ARN, resource share ARN, sender account ID, and status. Each invitation has a unique resource share invitation ARN that you need for accepting or rejecting. To accept an invitation, use AWS RAM Accept Resource Share Invitation with the Resource Share Invitation ARN parameter. The command returns the updated invitation object showing the status changed to accepted. After acceptance, the shared resources become available in your account immediately for most resource types. To reject an invitation you do not want, use AWS RAM Reject Resource Share Invitation with the same invitation ARN parameter. The status changes to rejected and you will not have access to the shared resources. Use this when you receive invitations in error or for shares you do not need. After accepting an invitation, you can verify access to shared resources. The AWS RAM List Resources command with resource owner set to other accounts shows all resources shared with you. This helps confirm that the expected resources are now accessible. You can also use service-specific commands to verify access. For shared subnets, use AWS Easy2 describe subnets with filters for the subnet IDs. For shared transit gateways, use AWS Easy2 describe transit gateways. For shared resolver rules, use AWS Route 53 resolver list resolver rules. These commands show the shared resources alongside your own resources. The code block on the slide demonstrates these commands in a typical workflow. First, listing pending invitations, then accepting one, and finally verifying that the shared resources are accessible. This workflow is common when onboarding a new account to use shared infrastructure. Monitoring and CloudWatch integration. Monitoring your resource shares is essential for maintaining visibility into who has access to what resources and tracking how shared resources are being used. AWS RAM integrates with CloudTrail for API logging and provides several methods for monitoring share status and resource usage. AWS CloudTrail logs all RAM API calls. Every action like creating a share, adding resources, adding principals, accepting invitations, and deleting shares is recorded. You can use CloudTrail to audit who made changes to resource shares, when they were made, and from what IP address. This is crucial for security and compliance requirements. Key CloudTrail events to monitor include Create Resource Share, Delete Resource Share, Associate Resource Share, Disassociate Resource Share, Accept Resource Share Invitation, and Reject Resource Share Invitation. You can create CloudWatch alarms based on these events to alert on suspicious activity like unexpected share deletions or additions of external principals. For monitoring share status, use the AWS RAM Get Resource Shares command to check the status of your shares. Shares can be inactive, pending, failed, or deleting status. A failed status indicates a problem that needs investigation, such as an invalid resource ARN or permission issue. You can also monitor resource-specific metrics. For shared transit gateways, CloudWatch provides metrics like bytes in, bytes out, packets in, and packets out for each attachment. For shared subnets, you can monitor the number of available IP addresses. For shared resolver rules, you can track the number of queries forwarded. To get a complete picture, you should also monitor from the participant account perspective. Track how shared resources are being used, such as how many instances are launched in shared subnets or how much traffic flows through shared transit gateways. This helps with capacity planning and cost allocation. The diagram on the slide shows the monitoring architecture. CloudTrail captures API events and sends them to CloudWatch logs. You can create metric filters to extract specific events and create alarms. EventBridge can also capture RAM events and trigger automated responses like Lambda functions for notification or remediation. Monitoring command line interface commands. Let me show you practical command line interface commands for monitoring your resource shares. These commands help you maintain visibility into your sharing configuration and identify issues before they impact your infrastructure. The first set of commands focuses on checking the status of your resource shares. The AWS RAM Get Resource Shares command, with resource owner self, lists all shares you own. Review the status field for each share to ensure they are all active. Any share with failed or pending status needs investigation. To see detailed information about a specific share, including all associated resources and principals, use AWS RAM Get Resource Share Associations. The association type parameter lets you filter for resource to see resources in the share, or principal to see who has access. This is useful for auditing access to sensitive resources. The AWS RAM List Principals command shows all principals for a specific resource share. The status field indicates whether each principal has associated status, meaning they have active access, or associating or disassociating, indicating a transition state. Stuck associations may indicate a problem. For compliance and audit purposes, you can use AWS RAM List permissions to see what permissions are available for different resource types. Then use AWS RAM Get Permission with a specific permission ARN to see the exact IAM policy document that defines what actions principals can perform on shared resources. To identify resource shares that might have overly broad access, search for shares with external principals enabled. Use AWS RAM Get Resource Shares with the Allow External Principals filter set to True. Review these shares to ensure external sharing is intentional and necessary. The code block on the slide shows these monitoring commands. Regular execution of these commands, either manually or through automation, helps ensure your resource sharing configuration remains secure and functions correctly. Consider incorporating these into your operational runbooks or creating automation that runs them periodically. Cross-region considerations. Understanding how AWS RAM handles regions is critical for designing a global multi-account architecture. RAM operates regionally, which means resource shares exist in a specific region and can only contain resources from that same region. Each resource share is created in a specific AWS region. The share can only contain resources that exist in that same region. For example, a resource share in US East 1 can contain subnets from US East 1 VPCs, but cannot contain subnets from EU West 1 VPCs. This means if you need to share similar resources in multiple regions, you must create separate resource shares in each region. When you share with principals, those principals gain access only to the share in that specific region. If you share with account number 22 ending with 22 in US East 1, that account needs to look in US East 1 to see the shared resources. The invitation also appears in the participant's US East 1 region. For organizations operating in multiple regions, you need a consistent approach to resource sharing across regions. One common pattern is to use AWS CloudFormation stack sets to deploy identical resource shares across multiple regions. This ensures consistent sharing configuration and reduces manual effort. Some resources are global, or have special regional considerations. For example, IAM resources are global, but RAM itself is regional. Route 53 resolver rules are regional and must be created and shared in each region where you need them. Transit gateways are regional, so multi-region connectivity requires transit gateways in each region with peering between them. For transit gateway multi-region architectures, you would share the transit gateway in each region with the appropriate accounts. Then, establish transit gateway peering between regions for cross-region connectivity. Each account attaches their regional VPCs to the regional transit gateway. The diagram on the slide illustrates a multi-region resource sharing setup. It shows how resource shares are created independently in each region, sharing regional resources like subnets and transit gateways. The participant account sees separate shared resources in each region and must manage their usage of shared resources on a per-region basis. Best practices and summary. Let me conclude with best practices for implementing AWS RAM effectively in your organization. Following these practices will help you maximize the benefits of resource sharing while maintaining security and manageability. First, leverage AWS Organizations integration. Enable trusted access for RAM in your organization, and enable automatic acceptance of resource shares. This simplifies the sharing workflow and reduces administrative overhead. Share with organizational units rather than individual accounts when possible, as this provides dynamic membership as accounts are added or moved. Second, follow the principle of least privilege. Share only the resources that need to be shared. Use specific principles rather than sharing with your entire organization when only certain accounts need access. Regularly audit your resource shares to ensure access is still appropriate and remove unnecessary shares. Third, implement a centralized network account pattern. Create a dedicated account for network infrastructure, including VPCs, transit gateways, and resolver endpoints. Share networking resources from this central account to workload accounts. This provides clear ownership, simplifies management, and enables consistent network configuration. Fourth, use consistent naming and tagging conventions. Name your resource shares descriptively to indicate what resources are included and their purpose. Tag shares with environment, team, and cost center information. This helps with organization, cost allocation, and cleanup of unused shares. Fifth, monitor and audit resource shares. Use CloudTrail to log all RAM API calls. Create alarms for unexpected changes to resource shares. Regularly review shares with external principals enabled. Document your sharing architecture and keep it updated as changes are made. Sixth, plan for multi-region from the start. If your organization operates in multiple regions, design your sharing strategy to accommodate this. Use infrastructure as code to deploy consistent resource shares across regions. Document which shares exist in which regions. The table on the slide summarizes these best practices with specific actions you can take to implement each one. Thank you for your attendance. Please consider subscribing to the channel and liking this video.